In the previous video, we have learned the northwest corner method that helps us to find the BFS. Now let's learn another method that may also help us to find the BFS, and this one is called the minimum cost method. Same as before, the purpose of this method is to find a BFS of a balanced transportation problem that contains m plus n minus 1 basic variables, and those basic variables, they do not form a loop. Okay, so keep in mind that although the name is minimum cost, it actually does not guarantee us to get the optimal solution with the total minimum cost. Okay, so don't think that this method gives us the optimal solution. No, it does not. It only helps us to find a BFS, exactly the same purpose as the northwest corner method. So if in the northwest corner method we fill the cell in the most upper left corner, here we fill the cell that has the lowest cost and then fill that cell with the value as large as possible. So here we see that this cell has the lowest cost, which is $1 per unit. So we fill that cell as with the value as large as possible. The demand for that column is 8. The supply for that row is 10. So we can fill that cell as large as possible with the value of 8. And do the update as usual, because 8 is exactly the same with the column. So we cross out the column and update the row from 10 to become 2, because out of the supply capacity of 10 for the second row, 8 has been taken to satisfy the demand of demand point 2. And then same as before, repeat the same procedure, find the cell that has the lowest cost. Here we have two possible cells, this one and that one. And if this is the case, you may pick either of them arbitrarily, okay? Suppose we pick this cell here arbitrarily, and then same as before, we fill that cell with the value as large as possible. So we can fill that with 2 because the remaining supply is 2 for the second row, and then we cross out the second row and update the first column. We keep going by finding the cell that has lowest cost. Now it's this one here. So this one corresponds to the supply of 5 and demand of 10. So at most we can fill this cell with 5. So put 5 there, cross out the row, update the column. So let's continue with the same fashion. Find the cell that has the lowest cost that has not been crossed out. So that is the cell. You can't fill this cell because it has been crossed out. You can't fill that cell either because the second row has been crossed out. Okay, so for this cell, the demand is 5, the supply is 15. So at most, we can put the value of 5 to fulfill the demand of this column. So 5 there, and then cross out the column, and then update the row. So now the remaining supply for the third row is 10. Now the remaining cell that has the lowest cost is this. The demand is 4 for that column and the supply is 10. So at most we can fill that cell with 4. Cross out the column and update the row. And finally, because this is the very last cell, we just fill it with the remaining numbers and then we cross out both columns and row. So we can only do this at the very last cell. Okay. And then same as before, we check do we have m plus n minus 1 basic variables. So we have 3 supply points, 4 demand points. So 3 plus 4 minus 1, we need to have 6 basic variables. 1, 2, 3, 4, 5, 6. Yes, we do have 6 basic variables. and they do not contain a loop. Same as before, if you try to connect these three basic variables, obviously they are already not a loop because a loop must not contain three consecutive cells. Okay, so these two requirements are satisfied. So minimum cost has been shown to help us to obtain a BFS. If you think the minimum cost method is very great because we always start by filling the cell that has the lowest cost as large as possible, so nothing can go wrong, right? Well, in some situations, things may go a little bit wrong. For example, in this problem here, if we use the minimum cost to create a starting BFS, and then we will fill that cell with 10, because this is the lowest cost, and then we cross out the first supply point, and then you can imagine that now we are forced to fulfill the demand for the second demand point and the third demand point with a very high cost. And you can imagine that the BFS on the right hand side here is actually preferable because we do not use the lowest cost, but we send the items to demand point 2 and demand point 3 with a much lower cost than if we use the second supply point, right? If we use the first supply point to fulfill the demand for the second demand point, the cost is only 7. Compare it with 80 here. If we fulfill the third demand point with the first supplier, then the cost is only 8 per item. Compare it with this $78 per item. So the point here is that we don't always get a good BFS using the minimum cost method because we do not look at the other possibilities, so we just look at the minimum one and fill that with the value as large as possible. Sometimes it's not very good and we actually need to consider the other columns or the other rows. So that is the weakness or the limitation of this minimum cost method. And then if you think that why do we have bother about this? Because we only want to have a BFS anyway. So whether it is good, it is bad, it is still a BFS. And you might be correct in that sense, but if you have a very large problem, usually if you have a good starting BFS, it helps you to reach the optimal solution faster. Okay, so it's true that minimum cost generates a BFS, but if we can have a better BFS, then it usually helps us to reach the optimal solution quicker. Okay, so in the next video, we are going to look at another method that may help us to get a better BFS. Before going on to the next video, I have one quiz question for you. So between the northwest corner and minimum cost methods, pick one out of these 4 statements that you think is true. I will give you a pause on the video to give you the time to think, and I will return after that pause. So the correct answer is C. A is wrong because it says minimum cost can generate an optimal solution. Well, it only helps us to generate a BFS, and we don't know whether the BFS is optimal or not. Maybe it is optimal, maybe it is not, but you can say the same thing with the northwest corner method, right? So the main point is both of them only generates a BFS. Maybe the BFS is optimal, maybe not, but the point is they only generate BFS. B is wrong because northwest corner also generates a BFS. And D is wrong because BFS cannot contain a loop. So the correct answer is C. So that's the end of this video, and see you on the next one. Thank you.